Hello everyone, welcome to my channel. When you watch a video, how do you actually learn from it? You're processing two streams of information at the same time. What do you see on screen and what you hear being said. Most AI systems only analyze one of those. But what if we could build a system that works like your brain, combining visual information and the spoken words to get the complete picture? That's exactly what we're going to build today. This is a multi-modal AI system that uses computer vision to read text from video frames, use natural language processing to understand transcripts, then fuses both together to create insights. By the end of this demo, you will understand exactly how computer vision and NLP work together. Let's dive in. First, let's install the needed packages. Then let's import the libraries we need. Notice the diversity here. We use CV2, OpenCV for video processing, NumPy for numerical operations on image arrays, and EasyOCR for computer vision engine, and the OpenAI GPT-4 model for our NLP engine. Also, we're going to use the data class for clean type-safe data structure. So we are combining classical computer vision, OpenCV, deep learning vision, easy OCR, and large language model GPT-4 into one system. This is the essential of modern AI engineering. So instead of like building everything from scratch. So this is a configuration. It might seem boring, but it's really critical. Um, so we load the OpenAI key from any environment file. Just be careful, never hard code credentials on your here on your code. So the code automatic set up our photo structures as well. Like data video would be for input videos, data frames, extract the images, data output, final reports. So why this is matter? So this is like pipeline pattern. Each stage has its own photo, making it easy to debug. So if OCR fails, you can check the frames photo to see what images it's working with. Before we run any analysis, let me show you the architecture of our system. This is where software engineer meets AI. We have 6 modules, each doing one thing really well. So this is a production quality code structure. I'm going to walk through each module, explain what it does, and why we build it this way. First, we define our data structure. This might look like boring, but it's actually critical to build like a reliable AI system. So this is like for OCR results. So this like represents like one text detection from OCR. So every time Easy OCR finds text in an image, we create an OCR result object. So text is the actual text that was detected. The confidence is how sure the model is, like 0 to 1. BB box is the bounding box coordinates. So where the text is in the image, and the frame number is like which video frame this come from. Um, Visual summary. So this class holds all OCR results for the entire video. So like total frames analyzed, how many had text, or detect text and key terms extracted and numbers found. So this is like the output of our computer vision pipeline, one object containing everything we learn from the visual analysis. The text summary, this holds the NLP analysis summary of content, what tone, like positive, negative, natural, um, claims, extract, entity mentioned, key points. And this one is the final output, it combining like a visual and text analysis. So like video metadata, quality score, timestamp, visual summary from OCR, text summary from the GPT-4 model, and then generate the insights. So then once you run here, it's a data class defined. So this is object-oriented programming for AI. We're not just throwing data around in dictionary. We have a structured typed validate data containers. When you are debugging, you can inspect any OCR result and know exactly what fields it has. Like when you're building larger system, this structure make it possible to scale. Now we get to the video processing module. This is all OpenCV, the industry standard computer vision library. So video pass here is a pass object, and the FPS is a float with a default of 0.5, and it returns any integer, like number of frames extracted. Let's highlight the key parts. So first part is first we open the video. So OpenCV creates a capture object that can read the video file frame by frame. This works with like FP4, AVI, all standard video formats. Then we get the video properties. Before we extract anything, we query the video's metadata as well, like how many frames per second, how many total frames. This let us calculate the duration and plan our sampling. So here is the math, like if the video is 30 fps and then we want a 0.5 fps, that means like one frame every 2 seconds. So we save like every six frames, 60 frames. So it's dynamic, works for every video fps. Then we extract the frames in a loop. So we're true here, if and if. So it's like classic video processing loop. Read a frame, check if we got a frame, um, and then if the frame number is divisible by interval, save it and repeat until video ends. So this is a function like to display frames in the notebooks. It uses a matplotlib to show images. So once you run this function, this cell, the frame extraction function will be defined. So OpenCV module loaded when we call extract the frames. It will decode the video on sample frames at our specific rate and then save them as GPG images. So now let's look at the OCR. This is where the deep learning comes in. We're going to teach a computer to read text from images. So first we need to do the pre-processing. This is very important for OCR accuracy. So first we convert the to gray scale. Like color images have three channels RGB. So grayscale has one channel, simpler for the neural network, faster processing. So text doesn't need a color to be readable. Then we're going to sharpen the image. So the kernel is a conversional filter. So for each pixel, multiply by 9, and then subtract the surrounding pixels. This enhance edges and make text boundaries clear. Think of like turning up the sharpness on your TV. Details became more pronounced. The function detect key terms. So after OCR gave us text, we extract the important terms. So this is like regress fonts, like all capture capital words. So this is like important. So we actually filter out common words like the and for noises we don't need. This function finds a structured numerical data, so like prices, percentage, and so on. Numbers appears in different formats. That's why we need to recognize all of them. So for each match, we pass it into a numerical value, track it if it's a percentage or price, and store the context, and also remember which frame it come from. Analyze frames with OCR. This is the main function. So basically, we initiate the EasyOCR reader first, and then we know the all frame images. And then for each frame, we pre-processing it, run OCR, filter by confidence threshold, and then store the results. So in here, this line is where the deep learning happens. Easy OCR. It runs crafted neural network to detect text regions, runs recognition network to read each region, then return the bounding box text and confidence. So we are leveraging a pre-trained model transfer learning in action. So once we run this function, the OCR function is defined. So computer vision module ready. When we run this, we'll be using like two neural networks trained on millions of images to extract text from our video frames. So we did not train those models. We're using transfer learning features learned on general text data sets to and then apply to our specific videos. Now we move to neural network, NLP function. So this is where we use ChatGPT-4, one of the most powerful AI model ever built. Um, at least I believe it. So look at this analyze tone function. So basically in here you see we have the prompt, analyze tone for this content, then run only one word, like positive, negative, natural, and then we try passing the transcript here. So this is a prompt engineering, crafting instructions to get the output we need. So it just like notice like you need clear see analyze the tone, and then you specific also need specific the output. So like return only one word in here. Also provide the options. So GPT-4 was trained on billions of words. It learned the pattern of sentiment, emotion, word choice. So when you ask, is this positive or negative, it can answer based on those known patterns. We're not training a customer sentiment model, like because it takes millions of example and we could compute. So we just use the pre-trained model. Um, so we just need to ask the right questions. Okay, let's move to next function, extract the claims. This is a little bit more complex. So like this is the prompt we have. We're gonna ask like for each claim, provide the text and type and confidence score, and then return a JSON array. So we'll specifically ask for structured output like JSON format, and then define the schema like what fields to include, and given the categorization instruction like it's a prediction, opinion, or factual. Okay. So through the training on massive the tags like it learn to distinguish those patterns. Mm. And now let's look at the similar function like extract the entities like find and mention topics, tools, concepts, and then we extract the key points like pull out the main takeaways. Also, we're gonna create a concise. So all those are using the same pattern like clear prompt, specific output format, and structured JSON output written. Um, and then this one, the analyze text with NLP, this is the function it's going to call all the other functions in sequence. So analyze tone, generate summary, extract claims, identity entities, and extract the key points. Each take a separate API call to GPT-4. So we could batch those, but separate them make it easier to debug and customize. So if you run this cell, a NLP function defined. So language models, it's loaded. So when we run this, it will using like 1.7 trillion parameters neural network to extract structured insights from text. So prompt engineering is the new programming. Instead of writing complex parsing code, we just need to write good questions. And now let's move to this multi-modal fusion functions. This is where the magic happens. We combining computer vision and the NLP. So we are doing like multi criteria scoring here. So you can see we actually look like visual evidence, numbers and quality claims, and the ratio, completeness score. So a single metric doesn't capture quality, but combining visual richness, like is there evidence on screen, and then any statements factual or just opinions. Also, like look the content completeness, like is the analysis through. So it's a much better way to measure the quality. Like you renting a restaurant, you don't just look at the price. It's like price is just a single metric. You consider food quality, service, and value, like overall ranking. So it basically just weighting different factors. So this is the fusion function. So first I'm calculate the quality score, and then I'm combining the entities from both source. So we merge the vision terms like from OCR with text entities from GPT-4, and then using the set remove duplicates. So this is from the cross-model correlations. So this is pretty powerful. Like if a Python appears in both video frames and the transcript, that's a strong signal. It is a key topic. Um, cross-model confirmation is more reliable than single source detection. And then we're going to generate resource. So we create automatic insights like find X data points in visual content, Y entity confirmed across both modalities, and then Z factual claims extracted. So those are useful insights, things you couldn't get from either source alone. Multi-modal fusion module is ready after running the not style. So this is what makes the system truly multi-modal, not just two separate analysis, but intelligent combination with cross-model correlation. So information from multiple sources, when they agree, provides a stronger evidence that than any angle source, like single source. So finally, we have our reporting module, making all this data human readable. So this function generates formatted markdown outputs, like quality score with color coding, high, medium, low, exactive summary, detected entities, claims organized by types, key points, visual statistics, basically. Um, like you may ask like why we do the markdown. Um, it's renders beautifully in Jupyter notebooks, and it's easy to read compare plain text. And then we're going to save the report to two different formats like JSON and Markdown. For JSON, it's more like machine readable. If you are going to building database, processing multiple video programmatically, and then feeding into other systems. Also, if you are going to create data analysis pipelines, for Markdown, like it just human report, like great for documentation, study guides, or if you want to share with your colleagues, also good for like reports and presentations. So once you run this cell, the reporting module loaded, we can now export our multi-modal analysis in formats that are both machine readable and human friendly. So, okay, now we already defined our entire pipeline. Um, you could just select your video and then extract frames, and then analyze the frames to extract the key insights. Um, so this AI techniques will demonstrate can work with any video content, tutorials, presentations, lectures, conference talks. So OCR doesn't care if it's reading Python code or recipe. GPT-4 also doesn't care if the transcript is about machine learning or gardening or investments. Please let me know what you think. I enjoy.